I'm excited to talk to you all today about some cool research that we've been doing in the FOUT lab. And this surrounds the idea that NMR spectroscopy and magnetic resonance imaging, MRI, are two important techniques that both suffer from sensitivity issues. And so they often require long times or high concentrations in order to achieve a reasonable signal. And so one solution that researchers have proposed is the use of parahydrogen. Perihydrogen is a nuclear spin isomer of hydrogen gas that has unique physical properties. And when it is applied inside of a technique known as perihydrogen-induced polarization, it imparts signal enhancement on the substrates that are around it. And that's called hyperpolarization. And so we can achieve this hyperpolarization one of two ways. You can either hydrogenate your substrate with perihydrogen, and that's through a technique known as Altadena or Pasadena, or you can just transfer that hyperpolarization from perihydrogen to your substrate through a technique known as SABRE through scalar coupling. And so in order to achieve this, researchers use transition metal catalysts, and second and third order transition metal catalysts are currently used for these types of reactivity. Our group is interested in the development of first order transition metal catalysts that are able to do the same type of reactivity to avoid some of the drawbacks associated with those. And so we've previously shown this cobalt pyridine transition metal catalyst to act as a hydrogenation catalyst as well as an Altadena catalyst. And so my research was to show if it was capable of doing SABRE catalysis. And so we first chose fluorofluorostyrene as a substrate to look at, and we looked at it on the proton NMR channel. And then you can take fluorofluorostyrene in the presence of your catalyst and perihydrogen, and by studying this reaction via NMR, we were able to see two products. We're able to see a little bit of the parahydrogenation product through Altadena, but we mostly saw the hyperpolarization of the protons associated with the intact molecule, representative of SABRE. If we look down at the carbon-13 NMR of this reaction, we're able to see that polarization is transferred to carbon-13 nuclei with up to 38-fold signal enhancement. This means that if you were to take a regular molecule of fluorofluorostyrene, you would have to take over 1,400 scans on your carbon-13 NMR in order to achieve this signal-to-noise ratio that we've accomplished in one transient. Taking a look lastly at the fluorine-19 NMR, we're able to see that fluorine-19 is able to be polarized, and that polarization extends across 7 bonds. So this work really demonstrates the first example of a non-iridium SABRE catalyst, the first order transition metal SABRE catalyst, and the first time that a variety of olefins have been used in SABRE. And so future work will look at optimizing these reaction conditions, as well as applying these hyperpolarized substrates in the MRI contrast agent field. Thank you.